So the next problem is number 12 from the review sheet, and it's about waves. So we have an amplitude of 50 centimeters. That's the height of a wave. Then we say it's going down a spring that's 7.75 meters long, and it takes 3 seconds to do that. So we'll add that to our picture. Here we have time of 3 seconds, and we have a distance of 7.75 meters, and amplitude is 50 centimeters. Okay, so if we keep on reading, it says the student who creates the waves moves their hand through 4 cycles in 1 second. So 1 cycle is when you start at the rest position, you lift your hand, go back through the rest position, go to minimum value, and come back to the rest position. So that would be 1 cycle. Imagine you're moving your hand up and down or sideways and making waves in a spring. So these waves are actually putting energy inside the spring, and these waves will move away from your hand towards the other end of the spring. And depending on the properties of the spring and the frequency and so on, the speed of that wave can change. So we'll need a few formulas to solve this. The first one is we need to know the frequency. So the frequency is the number of cycles divided by the amount of time. The next one will be a kinematic equation for speed equals distance divided by time. And finally, there's a waves formula that's speed again is frequency multiplied by wavelength. So the, the lambda, that's the symbol lambda, that's the wavelength. And that's just usually measured in meters in the with metric units. Okay, so the first thing we'll find is our frequency. So we're told in the problem that we're doing 4 cycles in 1 second. So that's 4 cycles per second. And we'll change that to hertz. So that's from Mr. Hertz, HZ. That's why it starts with a capital. And frequency is a small f. Okay, mine might look a little bit like a capital F. I'll just redo it. It's got the crossbar. So we don't use a capital F because that's reserved for force usually. Okay, so next part. We want to know what the speed of this wave is when it crosses our spring. So V equals d over t is 7.75 meters divided by 3 seconds. We can tell right away that the answer will be in meters per second, meters on top, second on the bottom. So our unit analysis tells us we probably have the right answer. So we're going to go to our calculator. We have 7.75 divided by 3 equals 2.58, 2.58, and a 3 that keeps on repeating. Third step now, we want to find the wavelength. So you might find it easier to do the triangle here. So V equals F lambda. So since we're looking for lambda, that means we will be dividing V by F. So lambda is V over F, and that would be 2.583 meters per second divided by 4. And hertz, if you want to put it in international unit, it's seconds to the power of -1. And when we want to find the final answer, we'll divide by 4. Previous answer divided by 4. That's 0.6458. And here we have meters per second divided by second to the -1. If you remember from your exponent rules, that's second to the power of 1 here. So what we have is second to the -1 is the same thing as 1 over seconds. So we have meters per second divided by 1 over second. So we're just doing some unit analysis here. Now if we rewrite this, we have meters per second, and instead of doing a division by a fraction, we will multiply by the inverse, which is second over 1. And you'll notice here that second cancels out the second that's on top. Divided by 1 makes no difference, so we're left with just meters. So that means that the answer is in meters, and since we're looking for a distance, that's a good sign. Our formula is probably, we did the right calculation. So we go and look at our questions, see how many significant digits do we need. So 50.0 is not used, we don't even look at this one. 7.75 is 3, 3.0 is 3, 1.00 second is 3. Now the 4 cycles, that's an interesting one because that's a counted number. It's not a measured number. So that means it has an unlimited amount of significant numbers. We don't count that one. So we just look at the other ones that are measured and it comes out to 3. So our answer will need 3 significant digits. So 1, 2, 3. That means because it's followed by an 8, the 5 will have to be increased by 1. So in conclusion, the wavelength is 0.646 meters. And that's the answer for this one.